Okay, we remove. No. We will start with ArcGIS Pro. So modules 3. So it's about the law enforcement decisions. So the geospatial approach to crime analysis helps decision makers deploy limited police resources and personnel, equipment, and facilities for maximum benefit. So here we will focus on law enforcement in Washington, D.C. and San Diego, California. So two cities that have successfully incorporated GIS technologies into their crime analysis and planning processes. We have the opportunity to use actual data to survey the crime situation in each city and recommend specific action plans on the basis of the GIS analysis. So here we will use walk time, directional distributions, and density mapping in the analysis. The maps we will produce will be the type of effective visual representations that in the real world assists decision makers and inform citizens. So we will do is here we will build in skills in the area classify and symbolize data. We already did many times. Calculate walk times. So I never done that before. Summarize the statistics. So yeah, we did. Perform geo processing, create and display tables, calculate directional distribution, and use the spatial analysis extension. And generate hexagonal polygons to summarize this data. It's kind of like central theory. So publish and share the findings in story map series. That's cool. So we did that a little bit. So GIS offers law enforcement agencies, LEA, a powerful tool to understand how reported crimes vary across both space and time. So LEA are increasingly adopting GIS as a tool to improve public safety and better allocate their finite resources to combat crime. So spatial data also helps police explore various factors contributing to crime. So here, there was a book or article talk about GIS and how to map the crime. Chimney and Rectify is a good source for more information about the growing importance of GIS in police work. So the crime data has limitations, and some criminologists and sociologists are concerned about the interpretation of such data using GIS. So note that the data in here is only for reported crimes. That our reporting process may result in some actual crimes not being reported. So for more on the limitation of crime data, there are some books or articles talk about it. So here we have to get the crime data, and the crime data comes from the District of Columbia open data. So the problem is the Metropolitan Police Department of the District of Columbia MPD is concerned about crimes near metro stations as commutes and tourists move around the city, and offers report a number of crimes in close proximity to the stations, and MPD leadership is considering changing how patrol resources are deployed. So the department is also concerned about whether some of its stations are seeing disproportionately larger numbers of crimes. They have been using GIS to analyze reported crimes in order to more efficiently place officers. So in this scenario, we are a police department GIS analyst who has been directed to investigate the following areas. So the crime by police district and police station service areas, crime within walking districts of metro stations, directional distribution of various crimes, hexagonal visualization. So, of course, we have to write paragraph, but I don't think so. Okay, so now our deliverables we're going to do is we will get the data and I already downloaded, so I have to start a new one. So here I will just say DC. Click a blank map and gonna navigate to my folder desktop, and as always, and gonna put in my folder. So next time I usually just put it on desktop instead of so many folders. That's really annoying. I know. So now I'm just gonna put it here. So click the name, click OK, and this one is just DC project DC. Okay, click OK. So now I have a DC. So the data we're gonna get is, so we will identify the problem. We must envision the kinds of data displays, maps, graphs, and tables that will address the problem. So we recommend the following developer for this exercise. So the first, there are 6 ones. So a map showing crime by district and crime within a 3-mile, service data of police stations, density maps of auto theft and burglary and homicide. So maps should have a contour lines, a map analyzing crime with a 3-minute walk time from metro stations, and a map showing the directional distribution of auto theft, burglary and homicide, hexagonal map of auto theft, and online story map series and publishing findings. So the question here are both quantitative and qualitative, and they identify key points that should be addressed in the analysis and presentation. So tips and tools. Topical instructions are given in the following exercises. So here, the more instructions are needed. So ArcGIS Pro provides these options. So we went through this many times. So that if I go to get a new map, so we can see that topic instructions are given here in the corner of the application bar. So we can do view help. So you can see the question mark. So the question mark is right here. You can see view help, and we already clicked that, and the question mark connects directly to the current online version of the help system, and context specific help topics may be available from specific tools or PAMs to help guide us through what we are doing in the application at the moment. So if you really like to click on it, that's fine. I don't, because when I don't know how to do something, I just Google it, and then usually just the ArcGIS help desk there to help me how to do things. Then opening help from these locations displays a help topic specific to that part of the user interface. On the ribbon, so point to a button to see a screen tip. So each geoprocessing tool box and tool has a corresponding help topic. We can open a geoprocessing tool with the ArcGIS Pro application and click the help button. So we can also point to a tool to see a displayed summary of the tool. We can also point to user interface elements in the geoprocessing pane for help on each parameter. And the tools can also be accessed using the geoprocessing pane by clicking the Analysis tab and then the Tools button. So a detailed explanation of each tool is provided within the specific tool menu. And the geoprocessing tools are presented in a gallery for commonly used spatial analysis tools. And this gallery will give us access to a subset of the full suite of geoprocessing tools in ArcGIS. So now we're going to organizing and downloading the data, which already did. Then I'm gonna extract the map package. If it doesn't work, now I know how to deal with it. So analysis, go to tools. So once we go to tools, okay, right here. So go to tools and we will say extract package. So extract package, and once it open it up, now we add data to the map and use the data help explore various components of the ArcGIS Pro interface. And ArcGIS Pro interface is unique in its ability to contain multiple maps and multiple layouts. When an ArcGIS Pro project is created, the project automatically creates a specific default geodatabase, and here we name it DC results. Well, I just say DC. I like it. So, where is our DC? Okay, DC data. an output folder. Remember that I'm gonna just put in that folder. Okay. Okay, so click run. Okay, then I should have the data. Let's see if it shows up. So now DC. No, it's not. Let's add a folder. And I don't think it's gonna like it. So I might have extract and copy the data there. So desktop, this, and this, and click OK. Let's see if the DC data is there. DC. Okay, DC results. Yeah, DC results. Okay, DC everything is here. But it doesn't have any. Okay, layers. Okay. Now this time, yeah. Okay, I think we have what we have and we do not have to extract in the Windows Explorer. So now we have extracted the contents of the DC data package to the data folder. We access the data. We must set up the project in the catalog pane, and the catalog pane gives us the access of each of the project components. All the maps that we create can be accessed from the catalog pane. So I already add the connection, so now we can see the folder connection will remain here. It will for a while, and then the DC crime. So when we add the data to the map, so ArcGISPro creates a layer for each data source, and the layer references the actual source data and can contain many different display properties. And for example, we can change the colors of layers and how they symbolized, and the layer name and labels. And now we can see data displayed in the contents pane and on the map. So what I'm gonna do, right click on it and add to current map. So then everything will be added. Now it is a good time to familiarize ourselves with the common GIS operations such as zoom, pan, zoom to full extent, and so on. We should take a few minutes to explore both the data and the interface. We will see that there is a contents pane, so which is right here, a map view, which is right here, and a catalog pane. So now we're going to turn the layers on and off in the this is checkbox, on and off, on and off, on and off in the contents pane, and become familiar with the different layers which identify the point, line. So this is point, and then lines, okay, and then polygons. So polygons, okay. So now so we will save the project. I'm gonna save it, okay, and the map derives its coordinate system from the first layer added to the map. So we can just see right click on map and go to properties. So coordinate system, that we have the 1984 auxiliary. So now what is the coordinates? So and then next we will set the output coordinate system for geoprocessing the same coordinate as the data frame or first layer, because this projected coordinate system most accurately preserve measures within the localized area. So now we will, in the catalog pane, we will select geodatabase and expand geodatabase. So database, so expand, and I have a DC geodatabase. Right now it's empty. So this will store all the process data files and DC crime. So this is the data source where the data comes from, and we will set the environments. Now, okay, so we will set the environments. So geoprocessing environment settings ensure that we can geoprocess in control environment. So here we will establish environment settings for the project, and setting these environments ensures that our data will be stored in the appropriate place with the designated coordinate system. And on the analysis tab, we will click environment, and so environment pane will come out, and then for the current it will be DC, and output coordinate system it will be UTM. So I'm gonna just say current map. No, not this one. Okay, crime. Okay, so it's NAT 1983 UTN zone 18. So if I'm look at the crime data, so that it should be there. Let me right click on it. Okay, I'm gonna click OK first. Let's look at it. Property, and then general. It's in source and spatial reference, and then we can see, yeah, 1983 UTN 18. Okay, so now this is DC. And we have to go back to environment settings, and for environment settings we have a geoprocessing extend. We will click processing. We will select DC extend, analyst masks DC. Oh, right here, DC. Analyst mask, it will be DC. There, click OK. Alright, so now we're going to create a process summary. So the process summary lists the steps that we need to do for the analyst next. The summary is important because it will allow us or others to reproduce the work. They know what's going on. Just like you have to do 4 major parts to prepare a fruitcake or something. So we suggest using a simple text document for the process summary and keep adding the summary as we work to avoid forgetting any steps. So the next list shows an example of the first few entires in a process summary. So we did was extracted the project package and produce map of Washington D.C., establish service areas for police stations, and calculate crimes with service areas. So we just did the first step, and now we're going to do the analysis and be able to create a map. Once we have examined the data, we complete map document and set the environments. So we are ready to begin analysis, and to complete the maps, we need to address the problem. So the first one is deliverable 1. So a map showing crime by district and a crime within a 3-mile service area of police stations. We will symbolize and classify data as usual. And on the police districts, so police district, I will say it's rename it a police district. So I'm gonna capitalize P and delete this underscore police districts. Okay, police districts. And for right click on it and go to symbology, we will do unique value. For unique value, we will use the field name, and then unique value name, and choose the correct color ramp, and we will click more, and I will clear this, and then OK. So police districts already have it there, so I'm gonna move on top, and we will label this district by name and click this police station and click label. So right click on this and just label it. Alright, so now we have the name of the district. And now we will move on to the contents pane and select police stations, and we will rename police stations and move up so we can see our police station. So the same way, okay, delete this underscore and capitalize P and capitalize S. So now for police station, we will change the symbol to project system to all and search police, and we will choose from there. So double click first and go to all style, changing to all style, and say police. Okay, so we will use the primitive large police station. Yeah, primitive. Okay. Alright, so now we have a police station. And then we will examine metadata and fields in attribute table. So a key aspect of working with ArcGIS is documenting the content we use. For example, we can open the attribute table of crime 2015 and see all the fields. So that's what we're gonna do. 2015 crimes, and right click on it and go to because it's a dot, so see a lot of reported crime. So open attribute table. So here is the attribute table, and examine the fields. So the first field, object ID, and is CCN. CCN right here is the crime complaint number. We will see fields for date, time, offense, and word, and and we will be sure to look at the bottom of the attribute data and notice how many crimes are listed. We will see that the crimes have been reported by block groups, and this indicates data sanitizing, which is the process of removing personal information such as addresses to protect privacy, and this process puts multiple crimes at the same location. And for instance, if there are 5 crimes committed within one block group and they are presented by a single location, just looking at the attribute table does not tell you the source of the data, so we can access and add metadata describing a layer using property window. So now I'm going to right click on the crime and go to properties, and we will click the metadata and entering the information here. So now I don't know whether this is read or I cannot add it on it, so read only. Okay, so now I'm going to change layer. Layer, so I would say layer has its own metadata. So now that I could type, so the title, so I would just say crime 2015, and for the text, just say crime. And summary DC index crime incident locations for 2015, and description DC index crime incident locations for 2015, and the data set contains a subset of locations and attributes of incidents reported in the ASAP. Oh, it has spelling check. That's really nice. Analytical services application. Okay, crime report database by the district. Of Columbia Metropolitan Police Department, MPD. And then we can say, please visit http //crime-map.dc.gov for more. Please visit, not visit, visit for more information. Visit. Okay. Credits. It's http://opendata.dc.gov, and we can say educational practice use only. Okay, so now right click on it again, and I'm gonna go to properties, and now we still have our metadata information. So cool. And now we have everything. Okay. So we will do statistics of crime by police districts. So we now compile some statistics of crime by offense or for both of the police districts, and within the 3-mile drive time from the police stations, we will use the spatial join tool, which joins attributes from one feature to another based on the spatial relationship, and the target features and the joined attributes from the join features are written to the output feature class. So here, The police district is the target feature, and crime 2015 is the join feature. So now I'm gonna go to join. Is this spatial join? Yeah, it's a spatial join. Okay, I have to click OK, close this out, and do a spatial join. So for spatial join, the target feature will be police districts and and then you can see we will put those dots in. So we don't have a like, oh, this is my house. I just say this district has all these. So that's spatial join. So the target layer, it will be the police station. Or police districts, not station. And the join feature will be the 2015 crime. And output feature, I will say police district spatial join. I just say crime, and then it's 1 to 1. Yeah, join from 1 to 1. Police district join PD crime. Yeah, PD crime. Yeah. PD underscore crime. Okay. PD crime. And then I think that's it. Join 1 to 1, and we don't have to do this, and click run. So the spatial join tells you the number of crimes per police district and calculating the percentage of crime per police district. per excuse me. Crime per police district will be much more meaningful. So we will rename the PD crime. So crime per police district. So PD crime. Okay, so it's added there. So I'm gonna rename it. Crime per police district. Okay, and we will see the join count summary, the number of the crime per police district, and we will find the percentage of crime in each district, and we will know the total number of the crime. So we will right click, close this out. So I'm gonna right click on here and go to the open attribute table. So for open attribute table, that we can see is crimes per police station, and we will have to go to field view. So for field view, we're going to calculate the field, and the field name I will add will be %. At the field, it will be %, and there's nothing, and it will be float. Okay. And % with 2 decimals. Okay, I will just say % with 2 decimals. Click OK. And now click Save. Okay, so OK, and then Save. And now we're gonna close out everything. Close out this, and the field will add here. Gonna scroll to the right. So %, it right now it is empty, so we cannot see anything. Okay, let me just float it. Okay, so % is empty. Then we're going to calculate it. So we will close the field, we already did, and we'll drag the % until it's to the right of the join count. So now we will have to do %. So we drag % field until it's to the right of join count. So when we first opened the attribute table of crime 2015, we noticed that the crime total, so let's see the crime total. I don't even remember. So the crime total, it will show up down here. It's a lot. It's 36,496 crimes in 2015. And we will right click on this field, %. Okay, so now we will do %, and we will right click on this join count %. Where's join count? I'm still looking, join count. Oh, right here, join count. Okay, so I'm gonna do statistics so that we can get maximum, minimum, and where is sum? Okay, sum. So that's how we have it here. It's 36,496. So, and then I'm gonna calculate field for our percent. So right click on it and go to calculate field. So for calculate field, it will be join count and divide by the 364. Oh, okay, 3636496 496, and then times 100. Times 100. That will be percent. And then I'm gonna run. So we have a 17%. Okay, that's a little weird. It asks us to percent with 2 decimals, percentage with 2 decimals. I have to, and then the book they show with more decimal points, so I think something wrong. They need to change it here. The image. Okay, so we will close the Joe processing pane, and we will close the percent police district, and back to the contents pane. So right click, close, 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 close. Okay, and in the contents pane, we will click crime per police districts. So I'm gonna uncheck this and go to symbology. So for symbology, we will do is unique value and go to percent, unique value, and then percent. It should be the last one, percent. Okay, so we can see the percent. And we will remove all decimals except 1 and add a percent sign. So, okay. Label, okay. So I have the percent, okay. Then I have to change everything, remove this, okay. And then I will say 1, 2, 3, 4. I think I just need 1 decimal point, okay. Okay, percent sign, percent sign. Okay. Percent sign. Percent sign. Percent sign. There. So now, okay. And we will right click and label police. Right click on this and label. So in the label field, labeling, and we will say name. Okay, the same we will say, oh no, percent field, we will choose percent. Okay, instead of this, I will say percent. It should be the last one. Percent, perfect. Okay. And then zoom to layer, sorry. Okay, zoom to layer. So now we should have the data. Okay. That's interesting. Okay, so okay, if I label percent, it will be labeled the value, and I cannot change the value. So that's interesting. Okay. Label. It should just show the value. Okay, labeling properties. So let's see. Oh, not DC. There. Okay. So, okay. That we will change the label from regular to bold. Okay, regular. I'm gonna change it to bold. Okay, from regular to bold, modify the police district crime layer symbology to an outline with no color. So I'm gonna do an outline with no color. So modify the police district crime layer. Police district crime. Okay, so we should now see police district symbolized by unique values based on the district name with the name percentage of per district appearing as labels. So now we will calculate the number of crime of different types based on the drive time from the nearest police station. We will use the network analysis tool to calculate a service area around the various police stations. The service area will determine the accessible area within a given drive time from the police station. And after creating the service areas, we will again use the spatial join tool to join the crimes to the service area. We will use the ArcGIS.com network data that is available when we sign into the organizational account. So this becomes interesting. That I'm going to do is I will have to do something for now. Get a boundary and make it visible. So now I'm gonna do it now. So I think I have to do one by one. So okay, so the easiest way is no color. Property. Yeah, it's the same. Okay. Red. Okay. Do to pool. It's just tedious in this case. If I can write code or something that I can just apply. Yeah. I did inversely. It's okay. If I do manual work, means I get time to familiarize with the DC district. So oh, this should be 2. Oh, it's slow. Three more. No color and the Mars red. 2. Delete. Click apply. Yes. Okay, no color. Okay, 2. One more. Yes. Two. Yay, perfect. Okay, so now everything is here. And we have the district, we know the percentage, and we can see this district is the highest. Okay. And we will do statistic of crime by police station drive time. So here in the contents pane, we will turn off the police district and the crime per police district. So turn it off. And we will turn on the police station layer, which is already on. And now on the analysis tab, we will click the network analysis, which is in analysis, and right here in the service area. Service area, notice that the service area layer has been added to the contents pane. It's adding now, so this layer together with its sub-layers will contain the subject of the service area. So that we will use the generate drive times from police station, and we will see a new contextual tab called network analysis add to the ribbon, so which is right here. So network analysis, so service area. So before we can compute a service area for each police station, we must load the station as input location for the service area solver to use. And next we will do is at the top left, we will import facilities and choose police station for input location. So now I'm gonna click here, and we will say police station for input location, police station. Service area input location will be police stations. Okay, and then that's it. Gonna run. We don't have to change anything. Next, we will set parameters for the service area to solve to use. So here on the service map, we will do travel settings to enter 3 full cutoffs. So cutoffs, I will say 3. And we will see the driving time is set to minutes. So driving time, it will be 3 minutes. I will only just say 3. And away from facilities, that's good. And in the output geometry, we will say split. Instead of overlap, we will do split, and we have a range, standard, precision. And at the top left of the analysis group, we will say run. So I think I have to run this first, and then I will run this one. So I'm gonna run this again because I might forgot. Okay, the service area solver has generated polygons, so it will generate polygons. I cannot move anything right now. Just wait. So it will generate polygons representing the drive time cutoff, 3 minutes, with each police station. So we will export service area polygons to a new feature class. We will name the output feature class 3 miles, and we will click run. So I thought 3 minutes, or 3 mile, and we remove the we will remove the service area, and then we will rename the 3 miles as a 3-mile drive time. So why not I just export it as a 3-mile drive time. Okay, that's the polygon. So I would just say right click on it, go to data, export features. So output, it will be 3 miles drive time. Okay, the issue is when you name them, you have to be careful. So now I did 3 miles drive time. So it looked like this, and the DC, I'm gonna just change it into a little gray color. So click apply. Yeah. Go back to appearance. Let's do 60% transparent. Click run. Oh, I don't need it. Okay, I already have it. Okay, close it out. 3 miles drive time, and then Now we're ready to do the spatial join. So we will click 3 miles drive time analysis and then go to spatial join again. So the target layer, it will be 3 miles drive time, and the it will be 2015 crime data. So still output feature class spatial join, that's fine. Click OK, run, and then I will rename it. So it was a police station crime. There. Okay, I have a police station crime now. That let me put on top so I can see what's going on. Okay, perfect. And now symbolize the police station crime layer by unique value and use the field join count. So now I'm gonna do is right click on it and go to symbology and unique value. Close this out, and that's weird. Is it a polygon or what? I just don't understand why I cannot do. What I'm gonna do is I'm gonna restart my ArcGIS Pro. So let me just restart everything. I saved everything. I'm gonna restart and open it again. DC. Okay, it's this one. Okay. Okay, so we're back and we will have to see what's going on. Right now it is still loading. So our task is we have to symbolize this layer. There. So now it's we're going to do is unique value using the join count. Yeah, that worked. Okay. And add values, and then add values, and we will not show everything. Okay, that's the join count, and we will save the project. Okay. We have to write a report about it, so we can using the join count, and we can classify it and do a little bit more work. So let me turn the police station layer on. Okay, and put it on top so we can see our police station. So those are the near the police station, and now we will do deliverable 2 density maps for auto theft, burglary, and homicide. So the map should have contour lines. So density maps shows the concentration of features per unit area or the concentration of a geographic entity. So here the density surface provides data throughout the area of interest and gives us a better indication of the distribution of crime in that area. So we will create 2 types of density maps. The first density map is a heat map, which is a density calculation that provides a graphical visualization dense to sparse in a particular attribute. So the calculation uses a Gaussian blur mathematical function which has both strength and weaknesses. So the density calculation involves a more sophisticated tool called point density. A point density calculation is not scalable but does have units, and the tool creates a new data layer. Density maps are frequently used in crime analysis to show where crimes are concentrated and to aid the search for pattern. So the MPD is particularly interested in auto theft, burglary, and homicide. And now we will duplicate and rename the map density analysis. So we will right click on the map one. So back on our, close this out, catalog. Go to view and catalog. So for catalog, I'm gonna right click on map and click a copy and right click on it and paste it. Paste. So we have a new one. And then for map one, I will change it into DC crime analysis. Okay, for this one, I'm gonna say it is crime density. The mouse is weird. I just have to wait a little bit and then close it out, 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 close it out. That's fine. Okay, now I have this is crime density. Okay, double click for crime density. So once we have a crime density, so we create a map showing redirect traffic patterns and drive times. So we want the new map to contain all the layers and symbolization shown in the DC crime analysis map. So in the catalog pane, we will right click, copy, and paste. So the DC crime analysis, which we did, and we renamed the map crime density. So after renaming the map, we can double click the map and see two maps to go between, and we can click multiple views together and dock them side by side, but it's not necessary because they are the same. So we can also link multiple map views together within the same project. So right now we don't have to do it. So this book they should do is, once we finish all the map, we can put it together and they talk about how to link views. So that's something I think this book could change, okay? So for heat map presentation, we will use a heat map to look at the total amount of crime, and heat map symbology draws point features as a representative surface of relative density. Heat map symbology is used when many points are close together and cannot easily be distinguished. And the approach displays the relative density of points using a color scheme, ideally one that has a smoothly varying set of colors ranging from cool, low density of points or to hot, high density of points. So the heat map symbology is a dynamic raster surface that changes when you zoom in and zoom out. For example, if the map a city crime hotspots, zooming out shows the bigger picture of crime activity across the city. When zooming in, shows more detailed density patterns in particular neighborhoods without having to reset symbology properties. So the heat map symbology is only a visualization of the data. Remember, the heat map here will scalable but will not have a unit to be represented as a new data layer. So now for the crime 2015, I'm gonna check it again and right click on it, go to symbology, and I can say heat map. So when I do heat map, and then I will just change the rendering quality to the fattest. So rendering quality, I don't see the rendering quality. Okay, the fattest. Alright, so and change the base map to imagery and examine the lines between the hotter crime area. So I'm gonna change it map, base map, imagery with labels. Okay, this is Washington, D.C. I think I just have to do a little different. Okay, when you change it, it just takes time. So fattest, and we will change the base map to imagery to examine the lines between the hotter crime area. So now I'm gonna untrack all these. So I don't want the service area, so we can see the heat crime better. So zoom in and zoom out to see how the heat map changes, and we will zoom in and zoom out, particularly useful when we examine smaller area of the crime. So like let's see, this area has a lot of crime, so let's jump in and see. And then you get a lot of small dots. That's really cool. Point density map representation. So we're going to do point density map. That could be cool. And once we do point density, we will have to do a little bit more, and then we will show the burglary and other things. So we're going to finish this, and then we will start with the durable map analyzing crime with a 3 minutes walk from the metro station. We will finish the first two. Okay, so the point density map representation. So now we will calculate 3 density maps. So to calculate a density map, so the computer must have a numerical value for each event. So we will click the crime 2015 and open the attribute table. And we will click new field and use the following parameters. So open attribute table, close this out, and then fields view. For fields view, I'm gonna click here. So I will say event. So now we have an event, and type will be short. Oh, for this it's event too. Format numerical, and then I'm gonna click save, and on the quick bar we click save, and then here we will close the fields, and we will scroll to the right until we see the event field. So we're going to calculate the event. So I forgot. Okay, right click on it, and then go to open attribute data and scroll all the way to the right, and we will calculate field. For calculate field, right click on it and calculate field. Okay, so once we have a calculate field, and in the expression box we will enter 1. Event, just 1. That's weird. So we will see that 1 is entered in each record, and we will close the attribute table by clicking there. And on the map tab, so we will close the attribute table by here, and we will do attribute. We will add a clause offense is equal to theft or auto. So then we will click run, and we will see. Okay, event is 1, click run. Everything should turn into 1. Okay, so let me check it out. There, so you can see our event is 1. And now we will see 1 is entered, and we will close this, and on the map tab we will see select by attributes that the offense is equal to theft or auto. Offense is equal to theft or auto. Click add this class and click run. So now so this steps selects the auto theft, and on the analysis tab we will do tools, and we will select analysis again, tools, and I will say point density. So the point density tool calculates the density of point features and around each output raster cell. So conceptually, a neighborhood is defined around each raster cell center, and the number of points that fall within the neighborhood is total and divided by the area of the neighborhood. And the resulting map has the units of area and are not scalable. So for the best practice, we will collect environments to ensure that both geoprocessing extend and the mask are set to DC. So let's double check again. So environments. So yeah, everything is DC. I have a one DC, and then it should be another DC. Raster masks, so raster masks, okay, DC, okay, geoprocessing extent, it will be DC. Click OK. Alright, so now we will open point density tool, point density, okay, spatial analysis, and we will use the following, okay, so the feature will be 2015 crime, and then population field, it will be event, okay, and auto raster, output auto raster, it will be auto theft. Output cell, it will be 70, and square miles, so unit, okay, unit square miles. Okay, double check again, crime 2015, and event, okay, auto theft in 70, and then square miles, okay, click run. So we will close the geoprocessing pane when it's done. We will close the 2015, and we will rename this auto theft. So we will right click on the auto theft and symbolize and change the classes to 5. Let's see, where did it go? Auto theft. Okay, now we can see it now. There. It's beautiful. So auto theft, I don't have to rename, and we will right click on it and change the class into 5. Go to symbology, and okay, classes 5, I do 5, okay, there. Okay, now I have 5 classes, and the labels, I will say the first one, it will be low. Then the second one, it will be medium low. After medium low, we will have a medium. And after the medium, we will say medium high. And then high. Cool. So now we will have to do is we will search for contour. We will do a contour line. So, and tools, contour. For contours are lines that connect locations of equal values in a raster data set that represents continuous phenomena. And here it's just crime. So the line features connects cells of a constant value in the input raster, and the distribution of the contour lines shows how values changes across a surface where a value has little change and the lines are spaced further apart where the values rise or remain rapidly. The lines are closer together. Contour lines are one of the primary reasons for using the point density tool to generate the raster surface. So it will be interesting to do the contour line, and once the contour line is finished and it's beautiful, and we will move on from there. So we're gonna continue. So the geoprocessing, we will open the spatial analysis for the contour line, contour tool, and the following input raster will be auto theft. And output feature, I would just say auto contour. I will not just do autocom. And then interval, so it will be 200, and then we leave other thing, click OK. So we will rename the autocom contour, and we will symbolize the line and change the color to red with the size of 2, and then we will save. So we will repeat the processes again for burglary and homicide. Oh my god. And then the next chart we will do the homicide and burglary. So we have a one contour, and then okay, we will have to do a lot of things. Okay, so now for the crime we will do offense we will do burglary, and we will do we had auto theft, and we will do burglary and homicide, So now crime 2015. Right click on it and go to attribute table. Okay, that's where we selected, and then we have to do is select attributes. So back to select attributes, and then we will add a class, and this time we will say offense equals to burglary, and click add, and then click run. And then we will do is point density. Which we have it here. So point density, so crime, it will be 2015, and use the popular event, and this rename it, we will say burglary. Okay, burglary, and then cell size, it will be 770, and unit is square miles. Okay, square miles, it's the same, square miles, and click run. So once we have the density for burglary, and then we will do is close this out. So now we have the density for burglary. Auto theft and burglary, and the same way we will change it into 5 classes. 5. Just type in 5. Okay, it's a lot easier. I don't have to click OK. And then burglary, right click on it and go to symbology again. The same way. Okay, the same way we have to do, and then we will do contour. The same way we will say low, and then medium low. After medium low, we will have median. And median high. The last one is just high. Okay. So once we have this, and then we can do is tools. So we go to the contour. So for contour, we will say burglary and contour burglary comb. Okay. And contour interval. Contour interval is still 200. So 200 and gonna run, and we will make the color into green. Okay, the first one is red. I'm gonna make this red too. Click apply. And then the second one. They don't need to show up anything, so okay, this will be green. 0.2, click apply. So we have a burglary, and then we will do yellow for the homicide. So homicide, okay. So then attribute table. Okay, then a new add a clause. Not this one, so it will be crime 2015. Okay, offense equals to homicide. Click add and click run. So then next step we will do point density. For point density, the same, we will say event. Okay, so this will be homicide. Homicide. And then this is 70 and square miles. Click run. Once we have a square miles, and then we will change the classification. Okay, we have a homicide, and right click on it, go to symbology, close this out, and then change the classification into 5. Okay, now we have a 5, and right click on it again, and then symbology. And the first one, it will be low, medium low, medium low. Oh, this is 6. Shoot. 5. How come it's 8? I think something wrong with my keyboard. That's why. Okay. So this will be low, medium low. medium, low. Now I have a medium low, and then I will have a medium. Once I have a median and then median high. Okay, and then high. Okay, so perfect. Okay, and then I'll just do contour. So for contour, we will have 200 homicide. Okay, contour homicide com. Okay, just say homicide contour 200. The same, everything is 200, and homicide contour okay, and everything I just do 2. It's okay. So now we can do the report for the police department by reporting the spatial distribution of the auto theft and burglary and homicide in the district. And we might want to change the base map to imagery and turn the layer on and off to reveal what is underneath. And this change is particularly effective with the contour layers. So, and then we will continue once everything is done. Okay, so the contour will be yellow. I like to too. It's bigger and nicer to see everything. Close this out, and I don't need to check this. So that's how it'll look like. We can see that homicide, theft is around here, and homicide and burglary is around here, and homicide is around there. So that's how it look. Okay, we will come back to finish out.